So we have this figure, figure 1. Figure 1 shows a sketch of part of the curve with equation y equals f of x, where f of x equals 8 minus x times log x for x greater than 0. The curve cuts the x-axis at the points A and B and has the maximum turning point at Q, as shown in figure 1. Write down the coordinates of A and the coordinates of B. Find f dash x. Show that the x-coordinate of Q lies between 3.5 and 3.6. Show that the x-coordinate of Q is the solution of this equation here. To find an approximation for the x-coordinate of Q, the iteration formula is used here. Taking x0 as 3.55, find the values of x1, x2, x3. Give your answers to 3 decimal places. So here's the question then. Summarized it here. So let's have a go at this then. Let's have a go at the first one, part A. Write down the coordinates of A and B. So here, when does this curve cut the x-axis? It's when y is 0, isn't it? So when does this equal 0? So 8 minus x times log x is equal to 0 when either this product is 0 or when log x is 0. So the two values there for the two roots. This one, it tells us move the x over and read from right to left. X is 8. So that's presumably the coordinate of the right hand side one. And this equation, log of 1 is 0, or if you unwrap the log, e to the 0. E comes down, swings up, hits that in the air. X is equal to e to the 0 then, which is 1, as we said. So these are our x coordinates of the points A and B. We actually need the coordinates, don't we? So A, which is the leftmost one, will be 1, 0. And the B coordinate will be 8, 0. So that's part A. Find f dashed x. Okay, so we got our function then. Let's just remind ourselves what it is. 8 minus x times log x. So fx is equal to 8 minus x ln x. And we need to find the derivative now. In part B, find f dashed of x. So this is part B. So f dashed then of x is equal to, it's a product, so we use the product rule, u times the v dx, log goes to 1 over x, plus v, which is the log x, times the u dx. Differentiate this, this goes to nothing, this goes to minus 1. So that equals 8 minus x over x minus ln x. So there's f dashed. That's part B. Now part C. Show that the x-coordinate of Q, that's the turning point then, lies between 3.5 and 3.6. So we do need to work out f dashed at 3.5. So we'll need to put that in the calculator. 8 minus 3.5 over 3.5 minus ln of 3.5. And we also need f dashed of 3.6, which will be 8 minus the 3.6, won't it, over 3.6, minus ln of the 3.6. So we need to tap these both in the calculator. Let's do that then. So the first one, 8 minus, so put a bracket, 8 minus 3.5. Close bracket divided by 3.5, and then minus the log, natural logarithm of 3.5. Close that bracket, equals, we get 0.0329, 0.033, 0.033, which is positive. And here, this one is equal to then, go back to our calculator, instead of 3.5, we need to toggle back and we need to put 3.6, don't we? So just change the 5 to a 6. Here, there's 3 places to change. Here, and also in the log, here as well, wasn't it? We get negative minus 0.06, minus 0.06 will do. That's approximately, which is negative. So the derivative changes sign. So f dashed changes sign. either side of Q. It changes sign between 3.5 and 3.6 as f dashed is continuous. F dashed is continuous. It follows that it's a turning point. It is a turning point. It follows that there is a turning point in between. There is a turning point in between. Right, let's just remind ourselves that we've answered that question then. Show that the x-coordinate of Q lies between, yes, and Q is the turning point. Show that the x-coordinate of Q is the solution of this equation. So that's part D. So let's have a look at that one then. So when does f dash equal 0 then, basically, because that's what we're talking about here. So here, the turning point happens when f dashed is equal to 0. That tells us that 8 minus x over x is equal to ln x. Move the x up. That tells us that, and read from right to left, x log x is equal to the 8 minus x. Then move the x over, and at the same time I'll take it outside a bracket, so you'll have the log x in the bracket, and then it will be plus 1 lot of x, won't it? And that's equal to 8. And so that tells us then that x is equal to 8 over, and write this the other way around. Move this from times to divide, and write it the other way around, so that it's in the form that the question asked for. So that's part D completed there. Let's just go back and check that. That's fine. Now we've got this recurrence relationship with x naught is 3.55, and we need to find those first three values. So this is part E then, the last part. We know that x naught equals 3.55. So x1 will equal 8 over 1 plus ln 3.55. x2 will equal 8 over 1 plus ln x1, and x3 will equal 8 over 1 plus ln x2. So these are our three values, and I'm just going to run them through the calculator. So this first one then, so it's 8 divided by bracket 1 plus ln 3.55, 1 plus natural logarithm of 3.55, close bracket. That's the logarithm bracket, close that bracket. 3.5289, 7, so it's 3.5290, isn't it? 3.5290. I'm just going to keep it to 4 dp, that's x1. x2 is equal to, so go back to the calculator, and we can put that 5290 into the calculator here, can't we? So 5290, and we get 3.5382, 5382, 3.5382, and x3 is equal to, so let's go back, and it was 3.5382. I'm going to put back up in here. It's 5382. So let's get this right. 382. And we get 5342. 5342. 3.5342. So to 3dp, that's 529. This is 538. And this is 534. So let's just write them down to the 3dp then. And that works out nicely, doesn't it? And that's all to 3 decimal places. So let's go back up and check that that's what it wanted. And that was part E, wasn't it? Let's just have a quick check of that. So find these three values to 3dp.